Okay, so welcome everyone to the post-contest discussion of Codeforces Round 953. I'm Abhinav Kumar and this is TLE Eliminators. So let's get started with the first problem. So in the first problem, we have uh, Alice has n books. The first book contains A1 pages, the second book contains A2 pages, the end book contains AN pages. Alice does the following. She divides all the books into two non-empty piles. Thus, each book ends up in exactly one of the two piles. Alice reads one book with the highest number in each pile. Okay, so what we are given here, we are given an array of size n. And what does that array represent? That represents just the even the first index represents the number of pages in the first book. The second index represents the number of pages in the second book, and likewise. Now, what it says that what Alice does, she divides all the books into two piles. Okay, so like each book she would put either in the first pile or in the second pile, and then she reads one book with the highest number in each pile. Uh, focus here, it's highest number. So number here means the index of the book, not the number of pages in that book. So like if we take this second test case, this two, it means the first book has two pages, the second book has three pages, the third book has three pages, fourth book has one page. So here the first book means the number of the book is one and number of pages is two. Second book means the number of the book is two and number of pages is three. Okay. So they would divide these books in either every book would go either into the first pile or the second pile, and then she would look into the first pile and the second pile. So in from both the piles, she would select the book with the highest number and she would read that book. Now we have to help her find the maximum total number of pages she can read by dividing the books into two piles. Okay, so we have to, so she is going to read two books in total, one from the first pile, one from the second pile. We have to maximize the number of pages she reads. Okay, that's what we have to do. Okay, so like if you look at it now, so like we are given an array, let's say this is 2, 3, 3, 1. Okay, so it means the first book has two pages, second book has three, third book has three, fourth book has one page. Now she would divide these books into two piles. Let's say she chose the first book and the second book. These two she kept in the first pile, and then these two books she kept in the second pile. It means the first pile would have the first book having two pages, and the second book having three pages. Okay, and in the second pile she would have the third book having three pages, and the fourth book having one page. So now from these two piles, she would pick up the book with the highest number. So if you see this pile, the book with the highest number is 2. So she would read this book. And then if you look at this pile, the book with the highest number is 4. So she would read this book. So the total number of pages she reads is this 3 plus 1. So 3 plus 1 equal to 4 we got. Now we need to maximize this thing. Okay. So how can we maximize this thing? So the first thing to notice here, the two books series, which two books would those be? Okay, if you look at the last book, the book with the number n in it. Okay, so this would be the book with the highest number among all books. So to whichever pile this book goes, let's say this book goes to the second pile. So from the second pile, the book with the highest number would be this only. This is for sure. Like to whichever pile this last book goes, it would always be the book with the highest number because it has the highest number in it. So this book is definitely going to be read. This is for sure. So if you are given an array, the last element of the array, this is definitely going to be read. Now among these elements, you the second one among these elements. So what would you want? You would want to read the book with the maximum pages. So this book, you are sure this is going to be read. So AN is definitely going to get added to the answer. Now you want to choose the book with the highest number of pages. So let's say somewhere AI, this book has the highest number of pages among these, excluding the last book. If AI has the highest number of pages, so highest among A of 0 to n minus 1 in this array. If this is highest, then what we can do? We can just choose from A1 to AI. This full we can keep uh, in one of the file and the remaining books in another file. So from this file, this book would become the book with the highest number, and we can read this book. So that's our best case. And for the remaining books, so all those books having a number higher than this would all go to the same file as AN. So those books would not be read because AN would be read. So finally, our answer would be what? It would be AN plus the max among A1 to AN minus 1. This would be our final answer. Okay, is this clear? Any doubts in it? Okay, so uh, I think if this is clear, so like in code, we have to do just nothing. We would just take the maximum element. We can just iterate through A1 to AN minus 1 and get the maximum element. We would name it MX, and then we would just print MX plus AN. This would be our answer. Or we can just use the max element function to get this maximum if we don't want to iterate. So you can see my code here. So this is the A problem. Let me zoom it a little. Okay, so this is the A problem. Now we just took the input and we just took the input for the array in our n-sized array. This was just for the input part. And then what I did, mx is equal to max element among a dot begin to a dot end minus 1. So we have excluded the last element. And among those, we took the max element and just we printed max plus the last element. So this was our answer. And this was a simple code for this. And like, if you want to know what would the complexity of this code would be, so like for input, we took O of n. And in finding this max element function, this works in O of n. It would go to each element and finding the maximum. It's same as iterating through each element and finding the maximum. You can do any one of them. Both would be O of n. And then you are just printing. So overall complexity of this code would be O of n. Okay. So this was the first problem. If there is any doubt in this, you can tell, or we would move to the second problem. Okay, so yes, I would be solving TLE problem. Okay, so let's move to the second problem. So in the second problem, we have Bob decided to open a bakery. On the opening day, he baked n buns and that he can sell. The usual price of a bun is A coins, but to attract customers, Bob organized the following promotion. So like we are given that Bob has opened a bakery and there are n buns he has to sell. And the usual price of a bun is A coins. Okay. But now to attract customers, Bob has organized some promotion. So what does it says? Bob chooses some integer k. Okay, first he would choose an integer k, which would be min of n and b. So now b is again some integer. Bob sells the first k buns at a modified price. In this case, the price of the ith sold bun is b minus I plus 1 points. Okay, so for the first k buns, so for the first bun, I would be 1. So the price of that would be b minus 1 plus 1. It would be b. For the second one, it would be b minus 2 plus 1. That is b minus 1, then b minus 2, then b minus 3. So it would go on decreasing from b. Okay, for the first k buns. And then the remaining n minus k buns are sold at a coins each. So the remaining buns are sold at a coins each. So this way, Bob is selling Now note that k can be equal to 0. In this case, Bob will sell all the buns at a points each. If k is 0, then this part would be excluded and all the buns would be sold at a points each. Okay. So help Bob maximize, determine the maximum profit he can obtain by selling all buns. Okay, so now we are given N, A, and B. These three things we are given, and we are not given K. So we have to take a K by ourselves such that the final profit he would get is maximized. Okay, so let's understand it, what it's trying to say. So we are given three integers, N, A, and B. Okay, and what does it say? We have to choose a K, okay, such that our profit is maximized. What would our profit be? So he has to sell N buns here. So it's saying for the first K buns, for the first K buns, our price would be B minus I plus 1. So what does it mean? So for the first bun, I would be 1. So it would be B minus 1 plus 1. It would be B. For the second bun, I would be 2. So B minus 2 plus 1 is B minus 1. Then B minus 3 plus 1 is B minus 2. B minus 3. Likewise, it would go up till the kth bun. So this was the first bun, second bun. For the kth bun, it would be B minus K minus 1. So this way it would go. And for the remaining buns from K plus 1 to K plus 3 up to N, the prices would be A. Okay. So like this, it is good. Now we have to just add up these prices, and then the sum of these prices would be our profit. Okay. Now we have to maximize this profit by picking a particular K. By picking some K, we have to maximize this profit. How can we do that? Okay. So now let's take an example and understand it more clearly what's going on here. So let's say A is 9, N is 9, A is 5, and B is, let's suppose, 8. Okay. So now in this case, we want to find our answer. So let's say K is something we take as 5. Okay. What would our profit be? It would be 8. Okay. For first bun. For second bun, it would be 7. So we are decreasing from B minus 1, B minus 2, like this. Then 6, then 5, then 4. So 1, 2, 3, 4, 5. So for K equal to 5, up to fifth bun, we sold at these prices. Okay. And then for the remaining buns, so 6, 7, 8, 9, we have to go up till 9. For the remaining ones, the price is 8. So we would sell at 5, 5, 5, 5. Okay. So like this way, this would be our profit for K equal to 5. Now, how can we maximize this? If you take a look, what it's actually happening, we are starting from B, we are then decreasing and going up till some value of B minus K minus 1. And then we are just constant with A. Okay. So if we choose a particular K, we can decide till which point we are just going to, like, if we are taking K equal to 5, we are just dividing this into like this. So till K equal to 5, we are going from B and reducing up till P minus K minus 1. And for the remaining part, we are taking just constant A. So what we could have done, if we have reduced the K, this would have come to the A part, and this 4 could have been 5. So this would have given me more profit. So what we will do, we would reduce this B until it reaches A. Okay. So we would reduce this B until it reaches A. Once it reaches A, then we won't reduce it further, because if we are reducing it below A, we could have sold it at the price of A. So why to reduce it below? Okay. So it's simple. We would take from B. We would, if B is greater than A, we would start with B. go on reducing till A, and then we would just continue with A. So in this pattern, we would go now. So we would just select a K in that way only. So, but what if B is less than A initially only? If we are given B is less than A, then we can just select K equal to 0 and just sell all of them at the price of A. Okay. So for this special case, we can just print the answer as N into A. We would sell all of them at, we would sell from B minus 1, B minus 2 up till A, and then A. Okay. So what would this sum be? Can we calculate this sum? Okay. So if you look till here, this is the sum of an arithmetic progression, if you see. So this sum would be like, this is sum from, you can, in one way, you can count it as if you do from B plus B minus 1, B plus B minus 1 plus B minus 2. If you do this up till 1, and you can subtract that from A plus A minus 1 plus A minus 2. This thing you can subtract, so it would be only up till A plus 1, okay, or up till A. So if you subtract this sum with this sum, you would get this particular sum. Okay, so first thing we can write is, so sum from 1 to B is B into B plus 1 by 2, and minus we can do A into A plus 1 by 2. Okay, so this through this we will get the answer for like till this stage. Okay, and for the remaining A's, what you can do, you can just add up A into the remaining. So how many remaining we got? We had to take n elements, and in this, how many elements we got? B minus A. So like B minus A elements are already done. So n minus B minus A. So these are much elements are remaining. So like this would be our formula. Okay, so like you can just derive this formula and just write it down. This would be our maximum profit we can get. Okay, one more special case in this. What if B is reducing, and like B is so much greater than A that before reaching A, all n elements are over. Okay, so if the difference between B and A, that is this thing, if the difference between B and A is greater than L, then this would become negative. So like this equation would be invalid in that case. So for the case when B minus A, this thing, the difference is greater than like n minus 1 or greater than equal to n, you can say, then in that case, we can write our answer as from B, we would take B into B minus 1 by 2 subtracted by how many elements we took? We took n elements. So the lower one would be B minus n. So like B minus n multiplied by B minus n plus 1 by 2. Like this thing we can write for the case when B minus A is greater than n. And for the else case, we can just write the above formula. Okay, so like if this thing is clear, just write down a yes in the chat. If there is any doubt in how we derive this formula, then you can ask. Because in this problem, just we had to derive this formula, just this sum of an AP we had to do. Okay, and then we can just directly print this formula. Okay. Okay, so I hope it's done by everyone. So we can quickly move to the code part. Okay, we took NAB as input. So these were our input. And the first special case, if B is less than A or less than equal to A, we can just see out n times A. Like there is no benefit by taking B if it's not more than A. We can just take n times A, we taking K equal to 0, and we can return. Okay. Now, if B minus A is greater than n or like n minus 1, so for writing greater than equal to n also it would work because B would get reduced till A. and then you have a all the way. So if you consider till a plus 1 or till a, both are same. Okay, so like that you can understand. So I had written n there. You can also write n minus 1, and both would be fine in this way. So here your answer would be, as I told, b into b plus 1 by 2 minus b minus n into b minus n plus 1 by 2. So as I had written there. So for this case, our answer was this. So that's exactly the formula I have written there. And for the here, I have printed the answer and returned. And for the else case, this is our answer. So as I written the formula, this is the first thing, b into b plus 1 by 2 minus a into a plus 1 by 2. So that's what I've written, b into b plus 1 by 2 minus a into a plus 1 by 2. And then I've reduced my n with b minus a and added a plus a into n. So this n is actually n minus b minus a. So what I had written, n minus b minus a. So that thing is only written here. I have reduced my n only and then multiplied a with n. It's the same thing. This is my answer. Okay. So I hope the second problem is clear to you. Uh, we got a into n b minus a. Then we use okay. So like is this not clear? How we got n in a into n b minus a part? Okay, so I'll explain once again. So what happened here? We took from b, we added b minus 1, b minus 2, up till a plus 1 we reached. This was one part of our answer. And then for the remaining, we took just a. Okay. So this part we calculated using b into b plus 1 by 2 into a plus 1 by 2. So this part was calculated. So this thing is the sum of this part. Okay, up till here. Now, what about this remaining part? So we have a's. How many times do we have a's here? We need to have a total of n elements here. So out of n elements, how many elements did we already had here? From b we moved till a plus 1. So there were actually b minus a elements already covered here. Okay, so let's say if b is 5 and a is 2, we would move 5 plus 4 plus 3 this much, and then we would move plus 2 for the remaining part. So how many elements are already covered here? 5 minus 2, 3. So that's what I'm writing, b minus a is the elements already covered, and we had to cover n elements. So n minus b minus a, these are the remaining elements. So this multiplied by a would give me the sum of this remaining part. Okay, so this thing plus this thing would give me the total sum. Is this clear? Whoever had asked that doubt. Okay. When b is 10 to the power 9 and we are multiplying b into b minus 1 to the yeah, so that's why you need to use long here. So if we are multiplying b into b minus 1, it would go out of the int range. So I have used long here actually. In my code, it would appear I have used int only, but above I have done hashtag define int long. So here I have done hashtag define int long. So all my int is actually long. So that's why. Okay. So is that clear? If you don't use long, this may go out of bond and you may get wrong. Okay. So now this was the code just, and what's the complexity of this code? So if you look, we just took 3 input, and then for one case, we just see out n into a, this is a constant time operation. In if we just stored answer as a formula, which is a constant time operation, and then see out. Then again, we wrote a constant time operation, and see out. So the complexity is O of 1 actually here. So it's the constant time operation. Okay, so we were given NAB as 1 in 9. So anyways, we had to write some O of N, O of 1 or O of log and something like that code. So it's a O of 1 and it's accepted. Okay. So is the second problem clear? Any more doubts in it? Okay, so then we can move to the third problem. Okay, so let's discuss the third problem. Let's call the Manhattan value of a permutation P the value of the expression P minus 1 mod plus P minus 2 mod up to Pn minus n. Okay, so we are given some Manhattan value of a permutation. For example, for the permutation 1, 2, 3, the Manhattan value would be 1 minus 1 mod, 2 minus 2 mod, 3 minus 2 mod. And for 3, 1, 2, we would have 3 minus 1 mod, 1 minus 2 mod, 2 minus 3 mod. So, like this. So actually, we are just taking the difference between the value at that position and the position. So if this 3 is at index 1, so we take the absolute difference between 1 and 3. Okay, and then this 2 is at index 2, we would take absolute difference between 1 and 2. This 2 is at index 3, we would take the absolute difference between 2 and 2. We would add those up, and this would give us the Manhattan value of this permutation. Okay, now you are given n and k. Find a permutation P of length n such that its Manhattan value is equal to k, or determine that no such permutation exists. So first thing, what is a permutation? A permutation means we are taking all the n elements from 1 to n one time in any order. So if we take each element from 1 to n, we would get n elements in total, and then we can arrange them in any order. That would give us a permutation of n. Okay. Now we are given as input the integer n and k. So, and we have to answer a permutation of length n such that the Manhattan value of that permutation is k. That's what we have to find out. And if it is not possible, then we would print just no in that case. And if it is possible, we would print yes and then also print the permutation through which we can obtain a value k. Okay. So now let's see how we can do that. Okay. So let's take an example. So, okay. So now let's see we are given n equal to 3 and we are given k equal to 0. Okay. So for k equal to 0, what would our answer be? That's the first thing. So first thing we can do for any permutation, if you look at the Manhattan value, if we place it as 1, 2, 3, the indexes are also 1, 2, 3. This would have difference of 0, difference of 0, difference of 0. This permutation would have a Manhattan value of 0. So whenever we want to obtain a Manhattan value of 0, we can just place 1, 2, 3 up to n. This permutation would always give me a Manhattan value of 0. Okay. Now, when would we have a different Manhattan value? Okay. So what Manhattan values can we have for a permutation? Let's try to analyze that first. Okay. So if we have 1, 2, 3, 4, 5, let's say for n equal to 5, I'm looking. Okay. If you place the elements as like this, you can have a Manhattan value of 0. Now, how can you increase the Manhattan value of this permutation? Let's say you swapped these two. You would make 2 here, 1 here. Rest elements would remain the same. So Manhattan values at these positions would remain 0 only. But at this position, if you see, the difference between 1 and 2 is 1. Difference between 2 and 1 is 1. We would have a Manhattan value of 2 here. Okay, now what else could we have done? We could have, instead of swapping 1 and 2, we could have swapped like 1 and 5, let's say. Okay, so let's say you had a 5 here and you had a 1 here. So this would be a 4, this would be a 4, and remaining would be 0. So 4 plus 4 would get 8 actually. So, and then again, let's say you swap 2 and 3. So you get a 3, 2 here. So 1, 1 from here. So plus 1 and plus 1 from here. You would get 10 in that case. Now, what we are actually doing here, if you take a look at that. Okay. first thing, if you take a look, okay, so we have this permutation from 1 to 5. So we can increase the Manhattan value by swapping, like swapping two positions. Okay, so whatever we do, if we have these n indexes and whatever permutation we arrange them into, so if we do the value minus index thing, so let's say you had like two, three, okay, okay, let's say you just swap these 1 and 5. So if you see, if you do the pi minus I, okay, not absolute, just pi minus I, what you would observe that 5 minus 1 would be plus 4, 2 minus 2 would be 0, 3 minus 3 0, 4 minus 4 0, and 1 minus 5 would be a minus 4. Okay, so if you had a plus 4 anywhere, you would get a minus 4. Now, let's say I did something else. Instead of swapping 1 and 5, I like cyclic swapped these first three elements. I made them uh, 2, 3, 1. Okay, and then a 4, 5. In that case, what would we have? If you see value pi minus I, 2 minus 1 is plus 1, 3 minus 2 is plus 1, 1 minus 3 is minus 2, and then 0, 0, 1. So if you look, if we got two plus ones, we got a minus 2. The net of this would always be 0. That's the first thing you can observe. Because whatever you do, if you are doing summation of pi minus I, it would be summation of pi and summation of I. And sum of both of them would be same. So it would always be 0. So if you write pi minus I, and the net of this would always be 0. Okay. So we would have some positives here, some negatives here. So what you can say the sum of positives values is equal to the sum of negative values, then only we can have a net 0. Okay. So when you do mod of pi minus I, okay, this is what we have to find. We have to find mod of pi minus I. So if you have some positives, let's say the sum of positives is x and the sum of negatives is minus x. So x is the absolute value. Okay. So these two are equal. Okay, the absolute values of them are equal. So what would your absolute value be? It would be x plus x, which would be 2x. And x is definitely an integer. It would be some sum of integers. It means whatever we do, our Manhattan value would be of the form 2x, where x is an integer. It means it would be an even integer. That's for sure. This we have proved right now. Okay. So if if you get k as odd, you can directly print your answer as no. Okay. If you get k as odd, you can directly print your answer as no. That's the first conclusion. Now we have to now only handle for k as even cases. Okay. Now when we have k even, what we can do, it means uh, as we told, k is of the form 2x, where the sum of positives is x and the sum of negatives is x. So we can just write x as k by 2. So we can just reduce this k to k by 2 and we can tell that as x. And now we have to just make this permutation such that the sum of positives, what's positives? It means pi minus I. So all those places where pi is greater than I, in those places we would have some, the sum of those places should be x. Okay, or k by 2. Our x is just k by 2. Okay, so if we are given a k, it's odd, just print no and return. If it's even, divide it by 2, and let's say this k by 2 is x. Now we need to find a permutation so that the sum of all those places where we have pi greater than I is x, or the sum of all those places where we have pi less than I is also x. Okay. Now how can we do this? Okay, let's just try to do something. Let's say we have n equal to 5 and k equal to 12. Okay. What we can do here, first we would just write down 1, 2, 3, 4, 5, whatever we have. Okay, and these are the positions. Now we have to do some swappings so that we get 12 as our k. It means our x is 12 by 2, which is 6. So if we swap like this 1 and 5, we would at position 1 we would have a 5. So all those values greater than like pi greater than I, there we would have a plus 4. And this would become 1, so we would have a minus 4. So we just satisfied 4 for our x. Now we have to take this value to 6. Now we can swap these two numbers and get a plus 2 here and make it plus 2 here, then minus 2 here. We can make it 6. Okay, so like whenever we swap these any two numbers, what plus we would get to our x, like the sum, uh, we would get the sum of positives or the sum of negatives. What extra are we adding? Whenever we are swapping a position 1 with position 5, we are adding 4. If you look at it, if we are swapping position I and j, you are adding j minus I to it. Okay, the difference between the two positions are getting added. And what's the maximum difference between two positions you can add in one swap? It's 1, and this would be n, so it's n minus 1. This is the maximum you can add in a single swap. And once you have swapped these two integers, then like you cannot swap them back, otherwise it won't add that value. If you swap this 1 with 3, which was already swapped, so if you add 5, 2, 3, 4, 1, and then you swap this 5 and 3, it would become 3, 2, 5, 4, 1. So like this 3 and 1, this from plus 4 you made it plus 2, and this 3 you got a plus 2 here. So plus 2 is plus 4 only. So there was no effect of swapping this. So if one element is already swapped, we won't swap it again. So what we would do, if we have 1, 2, 3, 4, 5, we can swap these two and have plus 4. So if we have wanted the k by 2 value, which I'm telling x, if this x was 4, we can swap the first and the last and just print our answer. We got x equal to 4. If x was 6, so after swapping 1 and 5, we can also swap 2 and 4 to make a plus 2. Okay, so but what's the maximum Manhattan value you can get from an array of size n? If you think like this arrays of this form, these are the indexes. This is 1, 2, 3, like with high time showing the indexes. If you keep the array in reverse order, that's the maximum differences you would get from any array. So the maximum Manhattan value you can get would always be when you place this array as in the reverse form. Okay. And what would that be? That would obviously be when you swap first with last, second with last second, and likewise, if you just reverse it. So how many are you adding to your Manhattan value? If you swap first with last, you added n minus 1. Second with last second, you added n minus 3. Then if you had more elements, up to half of the elements we would go. Likewise, we would add. So this sum would be the maximum you can, like the maximum Manhattan value you can get. And if k is greater than like the x, which is k by 2 is greater than this value, then you can print just no in that case. Okay. And if it is less than this value, then like how can we form this? We are going to look at it. Okay. So like what we can do, so 1, 2, 3, 4, 5. Let's take a bigger array now. Let's say we have till 8. Okay, if what we can do, if we have from first and last, we can swap and get plus 7. So whatever k we would have, we would reduce it to k by 2, which is x. So for x equal to 7, we would swap first and last and job done. Let's say you have x equal to 6, less than this. For x equal to 6, you can swap first with last second. This difference is 6, and you can just get it. Okay. And for x equal to 5, you can swap these two. For x equal to 4, you can swap these. Okay. So for x less than equal to n minus 1, you can from a single swap from 1 to 1 plus x, you can just swap, and in a single swap, you can get job done. Now, what if x is greater than n minus 1? So first swap, you would always do the greatest you can do, which is n minus 1. So you would reduce your requirement by n minus 1. So let's say you had x equal to 10 here. 10 was the requirement. You can reduce it by 7 by swapping first and last. So 10 has become minus 7, it has become 3. Now you need to do 3 more. So you can start from here and go to plus 3, and these two you can swap and get a 3 more. Okay. What's the maximum you can get from the second swap? It's actually 5. If you had 7 here, the maximum now you can get is 5. So if you had 7 plus 6, 13, x equal to 13. So at first swap, you can do 7. Then next swap, you can obtain a plus 5. Okay, so you can get 12. Now you want more. So from this 3, you would do one swap and get a plus 1. You made it 13. So likewise, what you can do at each step, you can just reduce your x by n minus 1 first, then n minus 3, then n minus 5. Likewise, you would reduce until you reach x is, let's say the current maximum swap is y. If y am first, y would be n minus 1, okay? Then y would be n minus 3, then y would be n minus 5. So if the current y is something and x is less than or equal to that, then you can just, instead of going for the maximum swap, you can just go for the smaller one and finish up your x and then just break your loop there. Okay, so like, did you understand what I'm doing? So like, uh, I can take one more example for n equal to 8 only, let's say. So if you are given k equal to, let's suppose 30. Okay, so your x would be 30 by 2, which is 15. So you have to obtain 15. So 1 and 8, you can add a plus 7. So like for n equal to 8, current y is 7, n minus 1. So like you can reduce this x by 7 and make it 8 by swapping 1 and 8. So you swapped 1 and 8. That's the first thing you did. You made a plus 7. Okay. Now, next, once you have done a full stretch of 7, you can do a stretch of 5 only, minus 2. Okay. So for 8, 8 is still greater than 5. So you would do a full stretch of plus 5 here and swap this 2 with 7. So you will get a 2 here, 7 here, and reduce this 8 minus 5, 3. And this y would again get reduced to 3, because now you have done a full stretch of 5, you can do only a full stretch of 3. Now this x, if you look, this is also 3, y is also 3. Now if this x becomes less than the y, you can just do a stretch of 3 here, make it 0, and then just break out of your loop. So you swap these two, you got a 6 and 3, and you have done a total of 15 on this. So this array would be your final answer. Like, did you got what I am trying to do? Okay, same idea, but could not implement it. Okay, so like we'll also see the implementation, how I'm doing. Okay, so the idea is clear now. So if any more doubts in the idea, you can tell. Okay, so now we are going to look at the code. Okay, so the first thing what I told, we took the input n and k. If k was odd, if k was odd, we directly printed no. So this is just C out no. You can assume it as C out no only. Okay. Ignore this. This is cout no. Okay. So we just did cout no and returned. Okay. Now, uh, if k is even, we divided k by 2. So this is our x actually. So I stored that in k only. I just divided k only by 2. Okay. So this is the required value where we have to reach. And then we just took our uh, array as a size of n plus 1 and then just assigned ai equal to y. So I am taking one based indexing here so that it's easy. So in our permutation also for swapping and all, we have one based indexing. So I'm taking one based indexing here. So A0 is irrelevant here from A1 to A1. I'm taking. So I'm assigning AI as 3. Now what I did, I took X as so the Y I wrote in my explanation is X here. Okay. So I hope you understand it. So this is the Y which I wrote in my explanation. Okay. So that is initialized with n minus 1. Now I'll start with, for the swapping part, I'll take an index. So for the first, initially when we had y equal to n minus 1, I would swap the first index with the last. So I would place my I here, and after each iteration, I would just increment my I. After the first swap, this I was swapped with the last element. Then this I would go here, and it would be swapped with the next last element. So from this would be actually swapped with I plus y, if you see. It was at 1, it was swapped with 1 plus n minus 1, which is n. Now, at second position, it would be swapped with 2 plus n minus 3, which is uh, n minus 1. Okay, so this likewise. And if the x is less than y, then I would be swapped with I plus x, so that you like you could have done a swap of plus 5, but you only needed 4. So you would only do till 4 and just break out of the loop. Okay. So I'm taking in I, I'm running a loop for I starting from 1, and this it would never go to n. I could have written n by 2 also, but anyways, I'm breaking it whenever I'm reaching my destination. Okay. So this upper limit does not have any effect here. Okay, so if this k is less than equal to x, it means my remaining, the x I told, and this is the y I told. So this is x less than equal to y from my explanation. In my code, it this x is k and my y is x. Okay, so if this the k is less than equal to x, it means the required value is less than the maximum jump we can do. So we would only do the jump of what is required, ai with ai plus k, and we would do k equal to 0 and break out of from this. Okay, job done. And if this k is greater than x, it means we cannot do it in this iteration. Then we would do the maximum jump we can do, which is ai with ai plus x, and we would reduce our k by x. So we have already done a jump of x. So we would reduce our k, and we would reduce our x minus equal to 2. As I told, I was doing y minus equal to 2 after every step. So that's what I do. And if this y, which is x in my case, if this gets below 0, then we would break out. Okay. So now, finally, after breaking out, if we are able to make this k as 0, then we are fine. But if this still some part of k is left, which we are not able to convert, if this k is greater than 0, we would print no in this case. So this is actually cout no. So we would do cout no and return. And if everything is fine, we would do cout yes in this case and just print our array from 1 to n. Cout. Next line. Okay. So I hope this was clear. The idea and the code, if everything is clear, you can write down a yes in the chat. If there's a doubt, you can ask. Okay. So let's move on to the next question now. Um, For some reason, this gave me wrong answer. And if I try to look at your view, okay, I can look at it maybe after the session. Okay, so let's discuss the next problem now. Okay, so the idea is clear now. In my code, I can look at it afterwards. Yes. Okay. Now, uh, let's move to the fourth problem. Okay, so in the fourth problem, we have elections are taking place in Berlin and there are n candidates participating in the election, numbered from 1 to n. The ith candidate has AI fans who will vote for him. Additionally, there are C people who are undecided about their favorite candidate. Let's call them undecided. Undecided people will vote for the candidate with the lowest number. The candidate who receives the maximum number of votes wins the election, and if multiple candidates receive the same number of amount of votes, the candidate with the lowest number among them wins. Okay, so like it's given. So what it basically means, we are given an array. Okay, so that array represents the number of candidates, number of fans for the ith candidate. Okay, so this A1 represents the number of fans for the first candidate. A2 represents the number of fans for the second, A3 for the third. So whoever are fan of a candidate, they would vote for that candidate only, obviously. And then we are given a C. That C are the people who are undecided. So what these undecided people would do, they would just vote for the candidate with the lowest number. So if the first candidate, first means the number of the candidate is 1, number means the index. So the candidate having the lowest index, the C people would vote to him. Okay. Now, after the voting, the candidate who receives the maximum number of votes wins the election. And if there is a tie, that multiple candidates receive the same maximum, the candidate with the lowest number among them wins. So the candidate having the lowest number has a lot of advantages. So the if there is a tie, the lower number candidate would win there also. Okay. Now you found these elections too boring and predictable, so you decided to exclude some candidates from them. If you do not allow candidate number I to participate in the election, all AI of his fans will become undecided and will vote for the candidate with the lowest number. Now, what you did, you decided to make it the elections a little interesting. So for that, what you did, you decided to remove some of the candidates from the election. So if let's say you remove the ith candidate from the election, then all the AI people who were fans of the ith candidate, they would become undecided and would vote for the candidate with the lowest number, simply. And then accordingly, the candidate having higher votes would win. Now, you are curious to find for each I from 1 to n the minimum number of candidates that need to be excluded from the elections for candidate number I to win the election. Okay, so for each I, what you need to find, let's say for the I equal to 3, you are curious to find. If I want this candidate to win, minimum how many candidates will I require to get removed? That's what it's asking. So if I want the I is equal to 3, the third candidate to win, how many candidates will I have to remove from the election so that this candidate wins? That's our question. And we have to find this for all I. For every candidate, we have to find this and just output our answer accordingly. So for the first candidate, we'll output answer for second, for third, for every candidate, we have to find this value and print it. Okay. So like let's understand this thing with an example. Okay, let's take the first test case. Okay, you are given this. It means your array is 203. So this is candidate number 1, 2, 3, or I can just take zero based indexing here, 0, 1, 2. Okay. It doesn't matter the lowest number wins, so it's zero based or one based. Lower would be lower. Okay. So this is the array we are given. It means the candidate with number zero has two fans. Candidate with number one has zero fans. Candidate with number two has three fans. Okay. Now there's C, you are given as C equal to 1. It means there is an undecided candidate. He would vote for the candidate with the lowest number. Okay. So now let's assume there is none of the candidates are removed. What would the result of the election be? If none of the candidates are removed, there would be all three candidates. These C would these C people would vote for the candidate with lowest number, that is this. So he would get plus one vote. So he would get three votes. First one would get zero. Okay. So 3-3 is tied there. So candidate with lower number wins. So this 0th person wins. So he would win if no candidates are removed. So what would my answer for I equal to 0 be? For I equal to 0, we needed to find minimum number of candidates to remove so that ith candidate wins. That's what we need to find for every index. So for I equal to 0, we want to make this 0th candidate win. So he is already winning without removing any candidates. So for I equal to 0, our answer would be 0. We don't need to remove any candidate. We need to remove zero candidates. Minimum would be 0. Now, let's see if we want to make this first candidate to win. How can we do that? Okay. So what we can do, we can remove this zero index candidate. Okay. If we remove him, what would happen? Uh, we would have only candidate number one and two. He is having zero, he is having three fans. So he had two fans, they are converted to C. Now our C becomes three, and all those would vote for the candidate with the lowest number. Now the lowest number is one. So these three would vote for him. So one would get three votes, two would get three votes. The lower number is one wins. Yeah. So if we remove one candidate, that is candidate number zero, we can make candidate number one win. So for I equal to one, our answer would be one. We need to remove one candidate. Okay. Now, how can we make this second candidate win? Okay. So like with zero removals, this first is going to win. So definitely it won't have answer as zero. Let's try. Can we make this second candidate win with removing just one candidate? So we can either remove the 0th one or the first one. So here we had removed the 0th one. In that case, the first candidate won, second didn't win. Okay, so let's try removing the first candidate. So we had 0, 1, 2, and it was 2, 0, 3, and C equal to 1. So let's try and remove this candidate. What would happen? If we remove this candidate, it means we'll have 0, 2, and 3. Now, these zero candidates get added up to the not voting ones to C. So 1 plus 0 would remain 0. So we would have C equal to 1. They would vote for this candidate. It would become 3. Now, the 0th candidate gets 3 votes. Second candidate gets 2 votes. Of the candidate with lower number wins. So the 0th candidate only wins here. So there was no advantage of removing just this candidate or just this candidate. So what we can do, we would definitely have to remove both of them for the second candidate to win. So if you remove both of them, all the votes would, there is only one candidate, all the votes would go to him. So for I equal to 2, our answer is 2. We need to remove at least 2 removals we would to make. Okay. So I hope the problem statement is clear what we need to do here. Okay. So now let's try to think what we can do here. Okay. So the first observation. So first, when we are given an array, Okay, some fans we are given, and we are given some value of C. Okay. The first thing we would find is if we don't remove any candidate, who is going to win? Let's say if we don't remove any candidate, we would add this C to A0. Okay. A0 would get a plus C here, and remaining would remain as it is. And among this, after adding, whichever would have the maximum votes would win. Let's say this index had the maximum vote. Okay. Let's say the ith candidate had the maximum vote. Okay. Maximum. Now, so for this ith candidate, the answer for this ith candidate would be 0. Okay. So the answer for I would definitely be 0 because with 0 removals, he is winning. So no need to do any removals. Now, let's try to analyze what would happen to these candidates. What's the case with these candidates? Let's take some candidate J such that J is greater than I. Okay. In this case, we are dealing with first. So for any candidate which is having a number greater than the candidate who is winning without removal. Now, for this candidate to win, what would you have to do to make this candidate? Let's say you did not remove this ith candidate. Can he ever win if you don't remove this ith candidate? So even if you remove any candidate from here, anywhere, those removals would get added up to C. And if this C, where would the votes of this C go? This would go to the candidate with lowest number. And until the time this I is there, this C votes cannot go to J because this I is less than J. It would go to I or some other index less than I, whichever is the first. It would never go to J. So this J is not increasing, that's for sure. And if we are not removing this I, it would remain at least mx. Okay. So if this mx was greater than aj, if aj is not increasing and this mx is not decreasing, it would still remain the same. And this aj, the jth candidate, cannot win without removing I. Okay. So that's our first conclusion. So for any j greater than I, he cannot win without removing I. He would definitely have to remove I. Okay, so let's say he removed I. Let's say I removed I. Okay. Um, okay, let's clear it up a little. Okay, for this jth candidate, let's say I removed I. Okay. Now, now when can this j win? So if I removed I, where the votes of this ith candidate would go? They would go to the smallest unremoved candidate. So if there is some candidate up till here which is not removed, these AI votes would go to him. It would not go to J. And if let's say that candidate had 0 votes initially, still it would now have MX votes at least because the MX here went to that candidate. So this MX would definitely be greater than AJ as this J is not increasing. So still this Jth candidate cannot win. So when can it win? When it would remove all the candidates before it. He would definitely have to remove all the candidates before this for this Jth candidate to win. That's the first thing. So if you found the candidate winning for the initial case when no candidate is removed, if I'm saying I is the candidate who's winning, then for any j greater than I would have, what would my answer for j be? Remove all these candidates before that. If you remove all of them before that, the votes of all of them would go to j because j is now the lowest numbered candidate currently. All those votes should go to J, including the vote of the maximum candidate. So now J is definitely going to win in this case. So for answer of J is just going to be J, like the number of candidates before that. If we are taking a zero-based indexing, then number of candidates before J would be J only. So answer J would be J for all J greater than I. And answer for I is 0. Okay. So after finding, so for any array, we found the uh, our winning candidate at 0 removals. We gave it 0 as our answer. For the ahead, we gave them J as our answer, whatever J that was. Now we need to find for this portion. Okay, whatever answer would be. Now let's see the first candidate. When can we make the first candidate win? Okay, so one case would be that the first candidate is only initially winning. This I is here only. Okay, so in that case, the answer for this would be 0, and for the remaining one, it would be just 1, 2, 3, 4, like that. Okay, so that special case can be dealt with. Okay, now let's consider the case when this candidate is not winning initially. Okay, so if this some particular ith candidate is winning, it has the maximum votes. When can the 0th candidate win? So we know for sure that all the votes of the unselected ones would go to him. Okay, so all these C votes would go to him. So it would have A0 plus C votes initially. And we are saying he is not winning. It means this is definitely less than MX. Okay, so how can we make him win? We cannot make him win with 0 removals. So what we can do? We can just remove this particular guy who was winning. If we remove this guy, all the votes of this person would now get to C, which is uh, uh, unselected or whatever, who have no fans, and these C votes would now go to A0 because 0 is the lowest number. So it would definitely get A0 plus C, which it was having, plus MX. So with this MX votes, he would definitely win the election. So for A0, we would definitely have our answer as 1. Okay. Now let's see for A1 what we can do. Okay. So for any other index, if you just look at this, if you had an array, I'm saying the ith candidate is winning. It has the maximum votes. For any j less than I, we already dealt with j greater than I. We had answer j only. Okay. So now let's see the case for any j less than I. Okay. So for any j less than I, what we can do? For this, we got our answer was 1. Okay, remove this maximum one. Okay. Now for some j, what we can do? The first thing is, if we want it to win, we would have to remove all the elements before that so that the votes of the removed candidates go to J. If there is any candidate before that, those votes would go to him. So if the votes of all these removed candidates go to J, and if this particular sum plus AJ, this whole sum till J, if this sum becomes somehow greater than or equal to MX, then this J candidate is going to win. But if this sum remains less than MX, then we would have to remove this candidate also. So it's just the case for any other J, what we can do, we can take the sum from 0 to J, the sum of this range. If this is greater than equal to MX, it means we are going to remove these many people, which are J people here, and we are fine. So in this case, our answer of J would be just J. Okay, and if this is not, then the else case, what we can write? We can write we would have to remove these many people plus this person also. So our answer of J would be actually J plus 1 for the L space. So like this way we have computed our answer for all the people from 0 to J less than I to J greater than I. For all the people we have computed our answer. Okay. So like you can just take an example and understand it more clearly. Okay, let's take this test case maybe. Or let's take the last test case. Okay. Mm, okay. So let's take this test case. Okay, what we have here, we have our array and we are given 2, 2, 2, 3, 3, 3 here. This is 0, 1, 2, 3, 4, 5. Okay. And we are given C equal to 0. Okay. So there is no those people who are not fans of anybody. Okay. So now first we would compute our initial answer without removing any people who is going to win. That would be our I. If we can compute that, then around that we can build up our remaining answer. Okay, how can we compute? We would add this C to A0. So like 2 plus 0 would remain 2. Now in this array, we would find the maximum. The maximum is 3 and this 3 occurs 3 times. So we pick the lowest index person. So this person is going to be our initial winner. So this would be our I. So our I is 3. So we can just say that our answer for 3 would be 0. This person would win without any removals. Okay. Now, then we would assign for all the j greater than I. J greater than I. So for these, we can just we look at our answer array. What we can write 0, 1, 2, 3, 4, 5. So for 3, we are assigning 0 as our answer. For all those greater than that, we are just going to assign j, as I told you. For j greater than I, we are always going to get j. So for this, we are going to assign 4 and 4. Why is it so? For this candidate, we would have to remove all these 4 for making it win. And for making this candidate win, we would have to remove all these 5 for making this. So that's why 4 and 5. Okay. Now, for the A0 candidate, as I told, it would have an answer as 1. That is, remove the winning candidate. It would have 1 as a 1. Now, for these remaining places, what I told, we'll check 2 things. First is, we'll check 1 thing. If the sum from 0 up to j is less than, or if this sum is greater than equal to mx, what is our mx? It is 3 here. Okay. Or mx is 3 here, the maximum value at index I. If this is greater than mx, then we would just say our answer as j, else our answer as j plus 1. That's what we concluded. So if you look at this particular index, the sum is 2 plus 2. So we have 2 plus 2 equal to 4, which is greater than 3. So we would have j as our answer. So it's 1, we would have 1 as our answer. And if we look at this 2 plus 2 plus 2, it's 6. 6 is again greater than 3. We would have 2 as our answer. Okay, so this would be our answer array. So it's going to be 112045. 112045. That's what we got. Okay. I hope the algorithm, and how can you compute this sum? That's the one thing. Optimally, you have to do an O of n approach for that. So first find the index I. You can find the maximum element in O of n. Just go to each element and find the maximum. Then what you would do, you would assign, if you find I, you would assign ai equal to 0, and all those j greater than I, you would assign at j. That would be an O of n maximum. And then for these remaining, you would start from here. Assign a0 as 1. And for these remaining elements, you would move one by one. You would maintain a variable sum, which would be a0 initially. And then you would just do sum plus equal to ai, so that you are just adding up these sums. and then you can just check this sum as greater than equal to ms. So in O of n more, you can just do this full operation. So an overall complexity of O of n would be fine to solve this problem. Let's look at the code now. Okay, so this is the D problem. So we took the input n and c and array ai. Okay, so now first thing we did was added c to a0 to calculate the maximum limit. Then j was the max element from the whole a minus a dot b. So we got the index of the max element through this function. Okay, so you could have done iterated through the array and got your max element. So anyways, you can do. I just did from the max element function. It returns an iterator to the pointing to the first element, which is the maximum in the array, and I did minus a dot begin to get the index of that. Okay, so my j here is actually the I explained in my explanation. Okay, so you can understand that my I and j are exchanged here. So my j is actually the index of the our initial answer. Okay, so we would assign our answer with 0. So our answer of j is already assigned to 0. Then for all those I greater than j, we would assign answer I as I. Okay, so as I told, for j greater than I, we would assign answer j as j. That's what we are doing. I and j are exchanged in code. And if j is not equal to 0, so one special case was there. If the initial answer becomes this, the my initial answer is only the first index, then what we can do, we can just assign this as 0 and the remaining as 1 2 3 4 5. Okay, so this would be our answer. So this a0, our answer 0 would be 1 in the case when our initial answer is not the 0th index. But if this is our initial answer is only the 0th index, we would have this 0 here. As you can see in this test case, in the first test case, we would have 0 here and 0 1 2. Okay, here also we had 0 here, 0 1 2. So whenever the first guy is the our answer, initial answer, we will have just 0 1 2 3 4 that arrow. Okay, so then in that case, we can, if j is not equal to 0, we can assign answer 0 as 1. If j was 0, we would have answer 0 as 0 already assigned to. Okay, and then we took a sum which started with a0, and then we added ai to it, and then we compared if this sum is greater than aj. Aj is our max element, the maximum value. If it is greater than equal to aj, we would have answer I as I. Otherwise, we would have answer I as I plus 1 thing. And then we can print that answer. So here I'm just doing C out answer. So this I have already defined as my C out for any vector. I have already overloaded this. So you can just run a loop and print all the elements for that. Okay. You can do like that. Okay, so this was the code for the fourth problem. If this is clear, you can write a yes. Then we will discuss E. Yes, we will discuss E. So if this problem is clear or any doubt is there, you can ask me. Okay, so I hope it is clear. Now we will move to the problem, the last problem of our discussion today. Okay, so what we have in today. Shasha has two binary strings S and T of the same length N, consisting of the characters 0 and 1. There is also a computing machine that can perform two types of operations on binary strings A and B of the same length K. What it can do, if AI is equal to AI plus 2 equal to 0, then you can assign BI plus 1 as 1. And if BI is equal to BI plus 2 equal to 1, Then you can assign AI plus 1 as 1. So these are the two types of operations that this computing machine can perform on the binary strings A and B. Stasha became interested in the following. If we consider string A, what is A? A is a substring of S, you can see, from L to R, and B is a substring of T from L to R. What is the maximum number of one characters in the string A that can be obtained using the computing machine? Since Sasha is very curious but lazy, it is up to you to answer the question for several pairs LI, RM that will do. So like we are given Q queries here. In every query, we are given L and R, and we have to find for the given two strings from the range L to R if we take the substrings. So S would become A, the substring of S from L to R would be A, okay, and the substring of T from L to R would be B. And among these two substrings A and B, if you can perform these operations, what's the maximum number of one characters you can get that you have to answer for each query? Okay. So like you are given a string of length n, which is 2e5, and then you have 2e5 queries. So like you can think in this, you can do some pre-computation for this n length string, and then each query you would have to answer in O of 1. O of 1 or O of log n at max. So you cannot answer each query in O of n. You cannot brute force that. N into Q would give us TLE. Okay, so you have to answer each query efficiently. So what pre-computations you can do so that you can answer each query in O of n that you have to do. So let's now understand this problem first. Let's take the first test case. Okay. Okay, so we are given this. What we are given this is our S, this is our P. Okay, so these two strings we are given, and then we are given two queries. So first query is L equal to 1 to R equal to 2. So for one based indexing, it is 1, 2, 3, 4. So from 1 to 2, this subarray is taken. So for this query, our A would be 1, 1, and our B would be 0, 0. Okay. Now, if you want to answer this query, so let's see the operations we had. Okay, what we can perform. So the first operation was AI equal to AI plus 2 equal to 0, then you can assign BI plus 1 as 1. So it means if you had any, if you had an array A was some 0, 0, 1, 1, 0, 1, 0, 1, 0, something like that, and B was from 1, 1, 0, 1, 0, 2, 0, 1, 0, 0, anything like that. What you can do, you can pick two indexes I and I plus 2. Okay. So like two alternate indexes, I and I plus 2. Let's say you pick this. If both of them are 0, what you can do, you can assign B of I plus 1 as 1. So if you take two alternate indexes in A which are 0, you can assign the middle index of that in B. This you can assign it to 1. This is what you can do. Okay. So like this thing you can assign it as 1. This is the first operation. Now the second operation is if you have bi equal to bi plus 2 equal to 1, then you can assign ai plus 1 as 1. So the same thing in opposite order. So now if you have two indexes b, let's suppose you had a one, let's suppose you had a 1 here and a 0 here. Okay. So if you have two indexes b, two alternate indexes in b which are 1. In case of A, we had two alternate indexes equal to 0, but here we would have two alternate indexes equal to 1. So if we have two alternate indexes equal to 1 in B, you can assign the middle index of that as 1 in A. That's what you can do. So after performing these two operations, you want to maximize the number of ones in A. Now, how are we getting a 1 in A by performing these operations? If you take a closer look, what we can do here is So let's say you had this. How can we have? So if we have ones at A, it's okay. We would have ones there. We want to convert these zeros to ones so that we can maximize our ones. Okay. How can we convert? So we can take two zeros and convert from those two zeros, convert a bi into one. That we can do. Let's take these two zeros, convert a bi to one. Okay. So that's the first thing we can do. And let's say we already had a one here. Okay. So let's say we already had a one here. Okay. These two ones have converted from A and we already had this one. Now what we can do, okay, so what we can do, we can pick two ones from B and convert an A to one. We can pick two ones from B and convert an A to one. So if you see through these two zeros, we converted this B, and then through these two B's, we converted this zero into one finally. So first thing you would do, you would from the initial A, the more zeros you have, you can convert more 0 to 1 in B, okay? And the more ones in B you have, you can convert more 0 to 1 in A, okay? So first of all, what you will do, from all the zeros in A, you would pick all the alternate zeros wherever you can pick and convert those uh, more and more B's to 1 as much as you can. And first of all, you will do all the operations of the first type, have more and more ones in B. And then once you have more and more ones in B, you can have more and more ones in A by using the second operation. That's the thing you are going to do. Okay. So now let's look at the test case now. So if you had this A and this B, now in this you have just two elements. You cannot perform an operation. To perform an operation, you would need at least three elements so that two are alternate and you are converting one of them. Okay, so with two elements you can perform no operation. So you have two ones in A, two would be your answer. From two to four. So from two to four, this is our substring. So we would have A equal to 111, B equal to 002. This we would have. So here, like you can you don't have any alternate zeros in A to perform any operation. And anyways, you have all ones in A. So in this, you would answer three. You have three ones in A. You cannot have more than that. Okay. So answer for this query would be three. Now, let's try to think how can we compute the answer so in this problem. So if we are just given a string, let's say you are given S, you are given T. Okay. Let's say you had just one query that compute your answer for the whole string S and the whole string T. Take this as A, take this as B, and compute your answer. What would you do in that case? Okay. What you would do, as I told, you would pick up all the alternate zeros that you can have in S, and then uh, from those zeros have some one in B as much as you can, and then like as much uh, ones you have in B, so that you can pick those alternate ones and assign some one in A. Okay, so that's what you would do. In this way, you would maximize the number of ones in A. Now, let's say you have no operations. Okay, or let's say you did all those operations and you obtained an A. Let's call this A as A dash. So A dash is my uh, string after, or I would call S as S dash. So actually, S dash is my string that after performing, okay, so after performing all the operations, the maximum ones we can have, we have put into S. So that would be S is converted to S dash now. Okay, S was our initial string, S dash is the converted with maximum amount of ones. So for the whole string, if we are given, we would just answer the number of ones in S dash. This would be our answer if we are given the whole string. Okay. Now let's say we have S equal to hmm, 0. Let's say you have 0, 0, 0, 0, 1, 0, something like that. And P is 1, 0, 1, 1, 0, and 1. Okay. Let's say you have this. Now, for this case, what would your S dash be? First, you will try to convert this T to T dash. So our T dash would be the T with maximum ones. So this 0 can be converted to a 1. This 0 can be converted to a 1. So it would have all ones here. Okay. What would your S dash be? You would try to have more and more ones. Yeah. So if you have a T dash of 1, 1, 1, 1, 1, 1, you can like this convert this to a 1, convert this to a 1. Okay. You can convert this to a 1, convert this is already a 1. So S dash you would have 0, 1, 1, 1, 1, 0. This would be your S dash. Okay. This was your S. So this is the S dash with maximum. So let's say you are asked for L equal to 1, R equal to N. Okay. Or 1, 2, 3, 4, 5, 6, R equal to 6. For this full substring, our answer would be 4. It has 4 ones. Now let's say you are asked for L equal to 1 and R equal to 5 only. So you are asked the answer for this substring only, from this till this. Or let's say L equal to 2. Let's say I take L equal to 2 and R equal to 5. Okay, so you are asked your answer from L equal to 2, R equal to 5. Okay, for this substring. Now, would we have our answer as this? No, because this one, if you look at this, how was this 0 converted to 1? First, we had these two zeros combining to make it 1, or that was not playing a role here. This one was converted through these two ones. Okay, so we needed this one to convert this to a 1. But in this particular case, we don't have this 1 in our substring. So we cannot convert this 0 to a 1. So this would remain 0 in our answer. Now, if you look at this one, so this one was already a 1. If you look at this was a 0 here. Okay, it was converted to 1 after this particular index from T was converted to 1 through these two zeros. So through these two zeros, this was converted to 1, and then through these two ones, you converted this to a 1, if you look at this. Okay, so to convert this 0, you required this particular 0. Otherwise, this 0 couldn't have been converted to a 1. So it would remain a 0 in the case and we don't have this particular substring included. So what you can see that whatever from S to S dash, all those indexes which are becoming from 0 to 1, you need to know that if it becomes from 0 to 1, what all indexes would it depend on for it to convert from 0 to 1? That you would have to keep, that you would have to store to answer the queries. Otherwise, you would not be able to calculate your answer. Okay. So let's see if there is an index I in the string A or in the string S. If there is an index I which is 0 initially, how can it become 1? It can become 1 in two ways. If you had a 1 1 in T already there, then this would become a 1 and it would depend on I minus 1 and I plus 1 to become 1. we can store that. Or there could be a case that the ith index is a 0, and in T, here you had a 1, but here you had a 0, but you had some I plus 2th index also 0. So these two 0 combined made this 1, and then these two ones made it a, this as 1. It may happen. So in this case, this conversion of this I, conversion of this I from 0 to 1 depends on this I plus 2th index, which is making I plus 1 in P as 1, which in turn is making this ith index as 1. So in this case, what I would say that this conversion from 0 to 1 depends on the index I plus 2, and that left side, this I minus 1 also it's dependent. So from I minus 1 to I plus 2 on these two, and this I plus 1 also. So for the full range of I minus 1 to I plus 2, it would depend. If all these indexes are present in our subarray, then this ith index would get converted from 0 to 1. Otherwise, it won't be converted. So like these are the only two possible ways. Can we have any ith index depending on I plus 3 or I minus 3? Okay, this can go to I minus 2 also. If this was a 0 and it became 1 to some these zeros, okay, then it may go to I minus 2. Okay, but in any case, would we ever have I depending on I minus 3 or I plus 3 or I plus 4, anything like that? No, right? If you analyze it more, you would realize either this ith index would become from 0 to 1 if both of these I plus 1 and I minus 1 in T are 1, or if someone is 0, it became 1 through some 0 from I plus 2 or through some 0 from I minus 2. Then it became 1 and then it became. So it would either depend on I minus 1, I plus 1, I minus 2, I plus 2. These are the four indexes it may depend on. Okay. So what we can do for each conversion, so like we can have S. In S, you can have just 0 and 0, 1, whatever string we have. So if we don't perform any operations for given L to our range, you can just compute the number of ones in L to our range. How can you compute that? You can take a prefix array, which is prefix sum of this string would, to that you can compute the number of ones in the range L to R. So this prefix of S would give you that for the original string without any operations. But for S dash, if you have some ones here, okay, if you have some ones which are converted from 0 to 1 from S to S dash, you would also have to store the indexes on which it depends for the conversion. So let's say this depends on I minus 1 to I plus 1, and this one depends on I minus 2 to I plus 1. So these also we would store in an array, in a vector of pair we can store on what the range of indexes on which the conversion depends. And if we store these two informations, what we can do, so if you have to compute for a range from L to R, okay, so our answer would be the prefix sum from L to R. So prefix R minus prefix L minus 1 of the original string. This is prefix of 1. One more prefix 1 we would say for S dash. This we can pre-compute for S dash. Now what I would do for the L index, I would check if it depends on some L minus 1, which is not in the range, then I would not add that answer. So L plus 1, I would check. But do I need to check for L plus 2? No, because at max it would depend from minus 2, which is on L, which is in the range. Same way we would check for R and R minus 1. But in between these two, from L plus 2 to R minus 2, we don't need to check. So in this, we would just add up the prefix 1 from, so we would add up prefix 1 from R minus 2 to L minus L plus 2. So L plus 1 if we subtract. So this would be for prefix 1. And what does prefix 1 store? Prefix 1 stores the sum of those conversions from 0 to 1 in S, from S to SS. That's what the prefix 1 stores. It stores the conversions from 0 to 1. How many conversions are there? Okay. So what we can do, we would have our answer equal to this, and then we would check for L, then we would check for L plus 1 and R minus 1 and R. These values we would check if there's a conversion from L to for the LF index, there's a conversion from 0 to 1 and it does not require any more does not require anything out of the range, then we would add a plus 1. Otherwise, we won't add a plus 1. And then we would add just plus of PR1 of R minus 2 minus PR1 of L plus 1. PR1 is storing the sum of the conversions from 0 to 1. Here we don't need to check in this range because everything would always be there. As I told, we would never have I depending on I plus 3 or I minus 1. So that's what we have to do. Okay. So let's like if our logic was a little maybe tricky to understand, but if it is clear, then we can move on to our code part. Okay. So we would try to understand it more from our code. Okay. So first we took the input SNT, and then we have this S dash and T dash, which I told I am taking as S1 and T. I just initialize with the same S1 equal to S and T1 equal to T. And then I did the conversion. So from 1 to n minus 1, I went. And then if for any I, if S of I minus 1 and S of I plus 1, if both are 0, then we can convert Ti to 1. Okay, so this way we are converting like the T dash, we are taking whichever were convertible, we converted it from 0 to 1. Okay, now we store this required vector of pair. This is going to store the range of the indexes required for the higher index. Okay, for it to get converted from 0 to 1. So if there's no conversion, I am just doing minus 1 comma minus 1 initially. Okay. Now, if you get SI equal to 1, if SI is already 1, just continue. I am looking for the case where SI is 0 and my S of I plus 1, S1 of I has become 1. Okay, so first we will do the conversion. When would, if SI is 0 and we want to convert it to 1, it would get converted when T dash of I minus 1 is 1 and T dash of I plus 1 is 1. So in that case, I can convert S dash to 1. Okay, so if this case is satisfied, we can convert this. This is the second operation. And once we have converted this from any S1 for S1, once we have converted from a 0 to a 1, we would store the required value. Required value would be I minus 1, I plus 1. This would like anyways be because I am requiring T minus 1 and T of I minus 1 and I plus 1. So this would anyways be. And if for obtaining this T also, if this is a converted one, it means I would require more. So if this Ti minus 1 was 0 and in T1 it was converted to 1, it means the required initial index would be I minus 2 because it was converted from a 0 in the I minus 2 only. Required I dot first I am doing minus minus. And same way, if this T of I plus 1 was 0 initially and it was converted to 1, then we would do required of I of second plus plus. Okay. So this way we are just doing the conversion from S to S dash and also showing the requirements for that conversion. Okay, requirement. So this thing is done. Now we are doing the prefix and prefix 1 as I told. So my prefix array is simply the count of ones in our SI. So if S of 0 is 1, it would store 1, and then prefix I is prefix I minus 1 plus if Si is 1, then a plus 1 to that. So this prefix array is simply the prefix array of initial string S. Okay. Now we would see prefix 1. So prefix 1 is initialized with 0. Now we would check uh, prefix 1 is prefix 1 of I minus 1. So that's for prefix. And then would we add a plus 1 if Si was 0 and S1I was 1? So if it was converted from a 0 to a 1, then we would do a plus plus on that. That's, so this is my prefix 1. It will store the count of conversions from 0 to 1. Okay, those are the extra values we can get to operations. Now we would take Q as input and go to a queries. So L and R are taken as. So in the question we were given L and R as 1 based indexing. So I just did L minus minus R minus minus to convert it to a 0 based indexing because we are using 0 based indexing in our solution. Okay. So first thing was our answer is prefix of R minus prefix of L minus. Okay, this thing first we did prefix of R minus prefix of L minus 1. So this answer at minimum we would have because these ones are already there in my original string. Now, what extra can I obtain from operations? That would see. So if the range is less than 4, if the length of the range is less than 4, so then in that case, there would not be any middle elements as I told. So we would check all of them. And if you check all of them, we would go I from L to R. And if there's a conversion from 0 to 1 and the required value is greater than L and required right range is less than R. So it means the required range falls between this L and R. If the required range falls in my sub-array range of L and R, then I'll do answer plus plus. Otherwise, I won't do answer plus plus. So here we can print the answer because we had only length less than 4. If you have length greater than 4, then we would check for L and L plus 1. L plus 2 is excluded. The same condition as I wrote there, this is copy pasted. And we would also check for R minus 1 and R, the same conditions. Okay. And then we would do answer plus equal to. For the middle elements, we don't need to check anything. We would do prefix 1 of R minus 2 minus prefix 1 L plus 1. Okay, for the middle elements. So then we can just see out answer and we are done. Okay, so like this was the solution for the E problem. Okay, so like you can try to, if you didn't get it, you can just try and like rewatch this explanation. So the logic is this only. It is, I hope it is clear. No, so we can end this session. Thank you very much.